In this video, I'm going to demonstrate how to calculate probabilities from the normal distribution in Excel, and I'm also going to reiterate the importance of drawing pictures to illustrate what you're trying to calculate to make sure that you don't make clumsy mistakes. I've got two practice exercises to work through. One is just a generic problem with a couple of numbers. Suppose you want to calculate the probability that a single value of x is between 10 and 14 if we somehow know that the mean is 12, the standard deviation is 2, and the variable x comes from a normal distribution. I haven't drawn anything in the picture yet. Your task is to set this picture up and make sure you label the two pieces of information that we have. That is, that the endpoints of the area or the probability that we're looking for are 10 and 14. And in the second question, suppose we've got a business application where a car manufacturer is concerned about the cab of their car being too small, and they want to make sure that they build the roof tall enough to make sure that something like 93% of their customers can fit comfortably in it. They need to know how tall 93% of their customers are, and maybe the tallest 7% they can kind of neglect. Again, your task is to set up the picture and label what this information is, this 93%. Now, you aren't given a mean or a standard deviation for this problem yet because we don't need it, and you'll see that towards the end. So I'll pause for a second, pause the video if you need to, set up those two pictures, and in just a little bit then I will add to the picture to show what your picture should look like. Alright, so in both pictures we should start by labeling the mean either as a center line or with a number if we have it. In the bottom exercise we don't have a number for the mean. And it's always a good idea to label the standard deviation. I tend to do it with an arrow. And as I suggested in a previous video, the point of inflection, or the point where the curvature changes from being kind of curving down like this to where it starts to curve and point back up, right around there is where one standard deviation is. And we'll label that down here too, even though we don't have numbers yet. The importance of labeling one standard deviation like this is to make sure that when you start labeling the 93% or when you label 10 and 14, that you make sure that your picture is roughly to scale. So this value right here is going to be one standard deviation above the mean. I didn't label it with an arrow, but right down here is going to be one standard deviation below the mean. And the same thing in this picture. And based on the numbers that we have, in this picture, the mean is 12. So one standard deviation below the mean is going to be 10. There's 12. And one standard deviation above the mean is 14. So for these relatively easy numbers that I've picked here, this probability of x being between 10 and 14 is the probability that our variable is between one standard deviation below the mean and one standard deviation above the mean. Now we already know that probability to be 68% from the empirical rule. If you wanted to look those probabilities up in a table in your textbook, most textbooks now show probabilities between the center of the distribution and a particular value that you look up. So if you looked up one standard deviation above the mean, or what's called a z-score of 1.00, the table would tell you that this area right here is 0.3413, I think. Yep, 3413. So to calculate that area, you would say, well, this is 0.3413 because the distribution is symmetric. This is also 0.3413, and therefore the two areas combined are 0.6826. And that's where the 68% comes from the empirical rule. Now in the picture in the bottom, where we don't have any numbers to label yet, except for the 93%. We could label that what we're looking for is the size of a car to fit the 93% shortest, and that is ignoring the 7% that are the tallest. So there's an area that looks, give or take, about like this if we've drawn our picture to scale. That's a strange looking arrow. This value right here is the one that we're looking for, such that the probability of being below that is 0.93, and that number is worth labeling. All right, now we turn to Excel. Again, I said that to look up the value from a table to correspond to this problem, you look at a z-score of 1.00, because the tables always work with z-scores or standard deviations. In this problem, we're looking for the value that has 93% below it, and we can piece together what we know about the distribution. Below the mean is 50% of values. So between this area right here, this center, up to the value that we're looking for has to be the other 43%. And now you can go to your normal table and look for the probability in the center of the table that says 0.43, and then work backwards towards the outside. I'll give you a second to do that. Pause the video if you need to. Answer coming. In my table, I found that value up here to be a z-score of between 1.47 and 1.48. Now that's not the height of the customer that we're looking for, but from z-scores we can work backwards once we have a mean and a standard deviation. For example, suppose the height of customers who buy this particular type of car, perhaps that mean is let's say 68 inches, 5'8", with a standard deviation of maybe 4 inches. That means that this value up here that we're looking for is 1.47 standard deviations, which is 4, above 68. So 1.47 times 4, and then add that to 68 inches, and you'll get some value. So to build your car large enough to fit the shortest 93% of customers, it needs to be, give or take, 1.47. We'll round that to 1.5. It's about 6 inches. It needs to be big enough to fit people who are about 74 inches tall. Now, the big task for this video is to learn how to look up all of those values in Excel. With the table, we looked up this z-score of 1.47 that would have 93% of values below it. And up here in the table, we verified the empirical rule that said that the middle 68% of values is between -1 and +1 standard deviation away from the mean. And so those z-scores of +1 and -1 are the ones that we need to look up these values of 10 and 14. So here's an Excel spreadsheet. Now the built-in commands that you'll need to look up these formulas all start with norm. And we see as I start typing here, it might be too small to see in the video, but there's this list of commands that come up. Norm dist, norm inv, which stands for inverse, norm.s.dist, and norm.s.inverse. The S stands for standardized. So you use the norm S commands to look up z-scores or probabilities corresponding to those z-scores. And if you use norm dist or norm inverse without that S in the middle, then these values will help you look up probabilities or values directly from a distribution without having to convert them into z-scores first. For example, here's a norm dist problem. As you open parentheses, again, this is probably too small to see in the video, there's this list of what are called arguments that you have to type into Excel. For norm dist, it says you're looking for an x, a mean, a standard deviation, and then whatever cumulative means. X is the value from the distribution that you want Excel to look up. And if you remember from our problem over here, we're looking for a probability that x is between 10 and 14, so a value like 14 would be a value from the distribution. Our mean was 12, our standard deviation is 2. So if we want to look up the value 14, comma, with a mean of 12, a standard deviation of 2, and then the last argument here is cumulative. If you want cumulative probabilities, you type in the word true or the number 1. That will give you areas. And if you type in false or 0, then it gives you the height of the normal curve, and there are very few business applications where that's ever useful. So type in 1 or true. And if you remember, the answer that we're looking for here should be something like 68%. And we see that that's not the value that we got. Now, the reason for this is that the way Excel calculates these probabilities is that it always gives us the area between negative infinity and the value that you plug in. We plugged in a value of 14 from a distribution that has a mean of 12 and a standard deviation of 2, and it told us that the probability is 84%. Now back to our picture, what Excel has just given us is this area right here as 84% between negative infinity up to 14 from this distribution with a mean of 12 and a standard deviation of 2. Now what we're looking for is the area between 10 and 14. And there's a couple ways we could calculate this. We could say that if this is 84%, the other 16% must be above 14. And because this is a symmetric interval around the mean, this is one standard deviation above and one standard deviation below, if this upper tail here has an area of 16%, the tail down here also has an area of 16%. That makes 16 plus 16% outside of that area. That's 32. And that leaves 68% for the middle. The other option is to go back in Excel and look up the area from negative infinity up to 10, and then subtract this whole area here of 84%, subtract from that this area up to 10, and that will leave us with the area in the middle. So we can go back to our Excel sheet here and say, what is the area in a normal distribution with a mean of 12 and a standard deviation of 2? What is the area up to a value of 10? And it is about 16%, which we already knew. So back here, if we label all of these areas, the area of this blue thing here was 0.84. I think I'll label right about there. And maybe in another color, how about green? We just looked up from Excel that this area right here has an area of about 0.16. So if we take 0.84, the area from negative infinity up to 14, and we subtract this 0.16, that'll leave us with the area in the middle, which is 68%. We've just verified the empirical rule. Now the other way that we might want to look up areas or probabilities is by starting with a probability and working backwards to a value from the distribution. We've already done that from the table. We wanted the value that has 93% of the data below it, and that probability of 0.93, or really a probability in the middle here of 0.43. From the table we looked up a z-score of 1.47. Now if we wanted to look that up in Excel, again remember that this 0.93 here is the area from negative infinity up to the value that we're looking for. and that's the areas that Excel gives us or requires. The table works a little bit differently. Now, since we're starting with probabilities and we want to work backwards, the functions that we're going to use are the inverse ones. We can either use norm inverse or norm.s.inverse. We open parentheses, and we see that the only thing that Excel is looking for here is a probability, and the probabilities that Excel wants are always between negative infinity and whatever value that we want. In this problem, we want the value that has 93% below it, and Excel is going to tell us the z-score from the standardized distribution, because we've used the norm s function, and it tells us that that z-score is right between 1.47 and 1.48, just as we already found. Then we could do the math in Excel and say, what is the value from our distribution? That is 1.47579 standard deviations above our mean of 68 inches. So to build that car to fit 93% of their customers, they have to make sure that it is suitable for at least somebody who is 73.9 inches tall. Now the other option, always equal sign first. Norm inverse without the s. Now if you open parentheses, it says that Excel is looking for a probability that you want to look up. We want the value that has 93% of the data below it. And we also have to tell it the mean and the standard deviation. We want the value that has 93% below it with a mean of 68 and a standard deviation of 4. Now what Excel is going to do here is it's going to look up the appropriate z-score with 93% below it, and then do the math just as we did in cell B6 here, where we take that z-score, multiply it by 4, add it to the mean of 68, and if everything works appropriately, we should get exactly the same answer as we did here. And now you see we did it in only one step using a norm inverse function directly, as opposed to using the norm s inverse function to look up the z-score, and then we have to do a little bit of extra calculation. Now if you wanted to, perhaps to save time on some quizzes, you could set these commands up, this one in particular, to say the mean that I want to look up is going to be typed into this cell, and the standard deviation that I want to use is going to be typed into this cell. And now it gives me an error message because you can't have a standard deviation of blank or 0. And we see we got the same probability that we did before. If I want to look up the probability of being below 10 with a mean of whatever is in cell E1 and a standard deviation of whatever is in cell E2, and then yes for cumulative, Excel can do that automatically. What's convenient about this is that I can now change these values and say on another exercise on a quiz, what if I'm supposed to look up a particular value, which I suppose I could also include as another input here, and say instead of having to type in this value of 10, why don't we just refer to this cell. So what is the value, or sorry, the probability of being below 50 in a distribution that has a mean of maybe 41.8 and a standard deviation of, let's say, 6? And Excel is telling us that the probability of being below 50 in this distribution is 91.4%. Now you could look that up in a table, and you'd have to say, well, how many standard deviations from 41.8 is 50? Well, that's 8.2 units divided by a standard deviation of 6. That gives you a z-score of about 1.3 or so. You go to your table, you look up 1.3. That gives you the probability of being between 41.8 and 50. You add 0.5 to that, you get your probability. You could do this in Excel a little bit faster by just looking up in that area directly. Likewise down here, you could create a new cell or a new place in Excel to look up that probability specify the mean and the standard deviation that you want to look up, and then just get your value directly. Again, be a little bit careful when you set up your pictures. Remember that the tables in the textbook typically give you the area between the center of the distribution and whatever value you're looking up, or the center of the distribution and the corresponding z-score. Whereas Excel always gives you lower tail areas, that is between negative infinity and whatever value you're looking up. So if you want to look up, say, the probability of being above 14, you have to know that if this is 84%, everything has to be 100%. So the rest of the 100%, which would be 16%, is this upper tail. Set up those pictures carefully, practice drawing them to scale, label all the information that you're looking for and what Excel or the table are telling you, and then you do some simple arithmetic to get the answer that you need.